Um, this question came up in the ask questions for the instructor part in Blackboard. So I want to look at the solution to this question. It's question 7 with your homework. And the question is about this Greek god Zeus gets a blacksmith to make a machine. And here's what the machine does. It pours out 2 gallons in the first minute, and then it doubles each minute. And then the question asks, in what minute interval? It says, find in which minute would this hypothetical machine pour out a single quantity of water. So which minute interval will have enough to fill up Zeus's cup? And we're told that the cup is huge. It holds 150 sextillion gallons. And then they help us out by saying that's a 15 followed by 22 zeros. Okay, so let's look. Get a new slide here. Alright, so we're told that each minute, like let's let x be the number of minutes. It has to be very organized. And then we're told that the number of gallons, it starts out in the first minute is 2. And then the second minute it doubles, so it's going to be 2 squared. The third minute 2 cubed. So then in the xth minute, then in the xth minute, it's hard to say. There is 2 to the x gallons. And we want to know when 2 to the x is equal to that huge number, 10 to the 22nd. Like it's a 15 followed by 22 zeros. And notice the variable's in the exponent. This is an exponential equation. We need to get the variable out of the exponent. So the way that we can do that is we can consider the inverse of exponential. It's the logarithm. And you can either use the natural log key, the ln key, to take the natural log of both sides, and then you can use this property to get x out of the exponent and then solve. And then your calculator can help you out with evaluating the logarithm for you. Or you can use the log on the calculator, the log key. Like you can either use the natural log key, the ln key, which is base e. It's the inverse of the exponential function base e. Or you can use this key, the log key that I'm drawing over here on the left. And that's the inverse of the exponential base 10. And these are both important because base e is important because the natural log is the inverse of the exponential. So the exponential is going to be an important base, like base e. And then the log, like this one right here, the log button, that one is important because we have a base 10 counting system. And that log, it just means that it's base 10. Like if there's nothing there. Like you can take a logarithm base 7, a logarithm base whatever. A logarithm is an exponent. Hey, I'm just realizing I need to do this fast because of YouTube. And you do have all the lectures, but send me questions if you have them. Let me just show the solution. Okay, because it's not working. Uploading videos to Blackboard, I keep contacting help. I keep getting error messages with each ticket. So let's use YouTube. That's what they recommended. They know what works best. Okay, so let's solve. Let's take the logarithm of both sides. I normally take the natural log, but I like that 10 over here. You see, the 15 times 10 to the 22nd. To use base 10, like logarithms base 10. That's why I'm choosing the log here. Okay, so log 15 times 10 to the 22nd. That's times. Right. Okay, so let's use this property that's based on the power rule. We can say that on the left-hand side, this is x times log 2. And then here, we can use that other property that's based on the product rule. We can say that this is log 15 plus log of 10 to 22nd power. Right, because all the rules of the logarithms are just based on the rules of exponents, because a logarithm is an exponent. It's what you raise the base to get the number. Alright, so here we almost got x by itself, instead by both sides by log 2. And then we have our answer. And I'm going to see how I'm doing on time. Okay, I'm doing good enough that we can put it in the calculator. Alright, so we're going to get x is going to be equal to log 15 plus, oh yeah, we can simplify further. We've got this log base 10. We can say that this is 22 because they're inverses. Like the exponential 10 to the 22nd is undone by the logarithm, the base 10 logarithm. Like this is the exponent, because it's base 10. It says log right here. I'll show you. Because right here it's base 10. Then we want to know the exponent that we raise 10 to get 10 to the 22nd. And it's obviously 22. Yeah, that's another one of those properties. Okay, and then in the denominator we just get log 2. And that's just simpler to say 22 instead of log 10 of 22. Okay, I'm going to go to this website that I really like. It lets me use a calculator on the internet. I posted an announcement for it, and it's convenient. So it's a calc. I get so used to using Google. Alright, it's called Calc 2.0, and it's web-based application, and there's an announcement. It has a link to it, and then there's also on that same announcement, if you like this, you might also like the graphing software. It's something you download and install, and it's excellent. It's better than the TI-83. You can save a graph and email it. See what I'm doing on time. Okay, yeah, let's enter this answer real quick. So the answer that we're looking for is log 15 plus 22 divided by log 2. So we'll just enter it here, log 15, and then we're adding 22. And we're dividing that by log 2, right? Okay. And then the outcome, that doesn't look right. I'm going to enter again. We had log 15, which should be a little bit more than 1 because 10 to some power is 15. 10 to the first is 10, 10 squared is 100, so 0 plus 1. Okay, so 10 to 15, then we're dividing by, no, log base 10 of 15, and we're adding 22, and so this will be a little bit more than 22, so 23, whatever, and then we're dividing by the log of 2. I don't know what happened the first time, but now we're getting 76.989. It's real close to 77. We're going to round it to 77, and we're going to get that x is approximately equal to 77 minutes. 60 minutes in an hour, so it's or 1 hour, 17 minutes. Alright, I'll see you around the discussion board, and let me encourage early participation in the week.